Okay, the theorem that we are going to prove now is about product of two polynomials. So let ax be one polynomial, bx be another polynomial. Let us define coefficient cn such that a0 bn plus a1 bn minus 1, a2 bn minus 2, etc. for every n greater than 0. In sigma notation, it is r goes from 0 to n, ar bn minus r. Now consider a polynomial cx whose coefficients are looking like this every time. C0 plus C1x plus C2 x square. So n is 0, then it becomes C0. N is 1, then it becomes C1, etc. So if we consider a polynomial like this, which is C of x, then C of x is called product polynomial of ax and bx. So what are we supposed to prove is, if a of x is a polynomial over real, b of x is polynomial over real, then C of x is also polynomial over real. Moreover, if any one of them is zero polynomial, then C of x is going to be zero polynomial. Therefore, we will not be interested in finding out the degree of C of x. But in case if none of them is a zero polynomial, then degree of C of x is going to be degree of A of x plus degree of B of x. That is what is the statement of the theorem. We have seen example, numerical example in last lecture. Now, solving numerical example, doing actual multiplication and getting the desired result. The result is known to us. We will get this result if we really multiply two polynomials. That is one part of the story. However, using all the letters and no numbers, abstract, a0, a1, a2, b0, b1, b2, c0, c1, c2, using all these parameters, if we could write down the solution of this, that is called proof of this theorem. I give you 5 minutes to try your level best to write the proof. After that, I will write on board which you should copy. Okay. We will write the proof of this theorem in two parts. Part 1, if any one of them or both of them are zero polynomials, then it is an easy case. Without loss of generality, let us assume a of x is 0. That means all the coefficients are 0. An is equal to 0. So by definition of Cn, this part AAR is going to be 0 every time, producing Cn is equal to 0 for every n from 0 to n. And therefore, C of x becomes 0 polynomial. Our point number 2 is proved. Now let us write down proof of the case where none of A of x or B of x is zero polynomial. Okay. It's very simple, very systematic. Okay. So if A of x and B of x, none of them is having is a zero polynomial, implies that A of x has degree. Let degree of A of x equal to capital A. That is, A of A is not 0. B of x has degree. Let degree of B of x is equal to capital B. What does it imply? B capital B is not 0. Leading coefficient is not 0. Okay. So after having done this, first we have to point number 1, that is C of x is a polynomial over reals. Therefore, we have to show finitely many coefficients are non-zero. So to show that there are finitely many coefficients or Ci's, finitely many coefficients, CR's are non-zero. Finitely many coefficients are non-zero. This is what we want to show, and therefore by the experience of the multiplication that we have, consider number n which is greater than a plus b. Suppose we consider a natural number n which is greater than a plus b, because a is degree of polynomial ax and b is degree of polynomial bx. And if I consider any natural number bigger than a plus b, then I am expecting that Cn, if I find out, it is going to be 0, right? So n is greater than a plus b. If n is greater than a plus b, how will Cn look like? By definition, Cn looks like sigma r goes from 0 to n, ar b n minus r. ओके, आता इथे मी न्यूमेरिकल तुम्हाला एक्झाम्पल देऊन एक्सप्लेन करतो हे काय करणार आहे आपण ते. सपोज a of x is ची डिग्री a of x, degree of a of x is equal to 7. Degree of b of x, suppose, is equal to 5. Okay, that is, this is what we are calling capital A. This is what we are calling capital B. So what is a plus b? A plus b is going to be equal to 7 plus 5, 12. Okay, so now let n is equal to 50, suppose. So what we are going to show now, C15, if I find out C15 which is equal to C15, then C15 is bound to be 0. C15 is bound to be 0. Do you want me to take an example here? Let us take example of smaller terms. Maybe we make it little smaller. Okay, let capital A be 3 and capital B be 2. Example, x cube plus 2x square plus x minus 3. That is A of x. B of x, x square plus x plus 2. Okay, so now let us write down what is going to be C of x. This is A of x, this is B of x. Let me write down C of x. C of x is going to be equal to coefficient of x raised to 5 is going to be 1. 1x raised to 5 plus coefficient of x raised to 4, 2 into 2. So this is one part, 2 plus 1, that is 2x raised to 4. Now what am I doing here? 2 into 1 plus 1 into 1 is nothing but this. This is what is being done as far as coefficient x raised to 4 is concerned. Then what will be coefficient of x raised to 3? X raised to 3 is generated by multiplying 2 with this. Therefore 2 into 2 plus 2, 4 plus 1. This will be 5. What will be coefficient of x square? X square can be generated by 2 into 2, 4, 1 into 1, 5, 4 plus 1, 5, minus 3, that is 2x. What is the coefficient of x? This into this, that is 2 minus 3 into 1, so minus 1. And what is the coefficient of x raised to 0? Minus 6. Okay, so when we are finding out these coefficients, we are actually following this rule. Okay, and now let n be, see this is 3 plus 2, 5, a plus b is equal to 5. So let n be 7, say for example. C7. Suppose I want to find out C7, then by this formula I should collect A0, that is minus 3, multiplied by B7 minus 0, which is B7. B7 is 0, plus When r is equal to 1, a1 b6, r is equal to a1 is 1, how much is b6? 0. When r is equal to 2, a2 that is 2, b5 which is 0. When r is equal to 3, coefficient is 1, b3, a a, how much, what is this? A0 1 2 3, a3, b4, we don't have b4, therefore this is 0. Okay, b, then next coefficient plus 0 1 2 3. Now a4 is 0 multiplied by b3, b is also 0, so this is unfortunate, both of them are 0. Then next is 0 1 2 3 4 5, a5. Now a5 is 0 but b5 is 1, b2 is 1, plus a6 is 0, b1 is 1, and a7 is 2, sorry, a7 is 0 and b0 is 2. I don't know whether you have understood this or not. So practically these terms become 0 because of second 0. These terms become 0 because of first 0. And because we have taken two jumps, I mean, if we would have considered 6, then this term would not have been there, only this and this. But more number of, I mean, if you consider this n much bigger than a plus b, then there will be many more terms with both zeros in between. That is the mechanism that we are trying to capture here. Let n be greater than a plus b. So Cn. How do you write Cn now? So now let us break this Cn in two parts. Sigma r goes from 0 to capital A, ar bn minus r, plus sigma a plus 1, r goes from a plus 1 to n, ar bn minus r. Now whatever we have understood here numerically, let me explain you algebraically over here. Now n is bigger than a plus b, and if r is equal to 0, then b, let me write down this term in terms of a plus b. So ar b, a plus b minus r. That is what this inside.
Sir, there must be R. You have written AN in
Huh?
second. In
A,
second sigma.
okay, so this is the first term. Let us consider first term. If r is equal to 0, a0 will be there, but a plus b, sorry, n is greater than a plus b, right? So whatever I have written here is not correct. A0 b n minus 0. Now will this n minus 0, as n is greater than a plus b, as n is greater than a plus b, the coefficient bn is of course going to be 0, because the largest coefficient in polynomial bx, which is non-zero, is bb, and every number after bb, capital B, is 0, and this n is a plus b. A is positive number and b is positive number, and it is n is greater than a plus b, therefore this is going to be 0. अरे समजतंय का?
Yes, sir.
सर परत सांगाल का कळलं नाही.
कळलं नाही? हे बघा इथे आता 7 घेतलंय आपण, n is 7 which is greater than 5, 3 plus 2, बरोबर आहे?
हो सर.
हा, तर आता a0 इथे पहिली टर्म काय येणार आहे? a0 b7, बरोबर? a0 b7. मग a0 आपल्याकडे आहे का? This is a0. Let me explain it in detail once again. taking those examples. What was our a of x? Unnecessarily hurrying it. A of x is equal to, apply a of x काय लिहिला पाहिजे आपण आता -3 plus x square plus x cube. Okay, let me write this down. A0 plus a1x plus a2x square plus a3x cube. So can you tell me what is a2? How much is a2? 2. How much is a3? 1.
1.
How much is a0? -3. अरे समजते का?
हो सर.
Yes, sir.
And what is capital A here? 3. दिसतोय? Degree. Is a3 non-zero? Yes. a3 which is equal to 1 which is not equal to 0. बरोबर चाललंय? How is b of x looking like? 2 plus x square which is equal to b0 plus b1x plus b2x square. बरोबर आहे? So what is b2? 1. b1 1. b0 2. Okay. आता आपण c of 6 लिहूया. c of 6. फॉर्म्युला काय सांगतो? What is c of 6? 6 here. c of 6 is a0 b6 plus a1 b5 plus a2 b4 plus a3 b3 plus a4 b2 plus a5 b1 plus a6 b0. That is what this formula is. So if I want to find out a c6, I must use this formula and put the values a0 -3 b6. Oh, I have b2 which is degree 2. Here capital B is equal to 2. So degree of b of x is 2. So every number greater than 2 it is going to be 0. So b6 is 0. दिसतंय का मुलांनो?
हो
b2
सर दिसतंय.
non-zero. Everybody after that is 0. So plus what is a1? a1 is 1. And how much is b5? 0. How much is a2? 2. How much is b4? 0. How much is a3? A3 is 1. How much is b3? Again 0. How much is a4? Oh, I am exhausted with a's now. a4 is 0. How much is b2? Oh, I have b2 with me, which is 1. How much is a5? 0. How much is b1? 1. How much is a6? 0. How much is b0? 2. After doing all this, we find it equal to 0. So if you happen to take this number n, which is 6 is greater than 3 plus 2. If you happen to take this number greater than 3 plus 2, c of this number becomes 0. And it is going to be for all numbers greater than 5. And that is how we will prove that there are finitely many non-zero numbers. Okay. So this is what is the mechanism happening. And at this point, it flips. At this point, it flips. Earlier terms are 0 because of B, and later terms are 0 because of A. Same is the story here. So I am breaking it at capital A. So when R is equal to capital A, when R is in our case, when R was equal to 3, that is this, we got the coefficient which is positive, or which we got the coefficient which is non-zero. Because n is greater than R, it is taking bigger than, so n is greater than A plus B, out of which we removed A. Okay, So the quantity n, if we remove a from both sides, n minus a becomes greater than b, and therefore when r is equal to a, this is n minus r, which is n minus a, becomes bigger than capital B, and everybody greater than capital B, BB is 0, and therefore all these people are 0. Okay. The moment we take r greater than a plus 1, the highest non-zero term in polynomial a is aa. This is non-zero. Everybody after capital A is equal to 0. A capital A plus 2 is equal to 0, and so on. Therefore, this summation will be 0 because of AR. This summation will be 0 because of Bn minus R. And hence, for n greater than a plus b, Cn will be always 0. Hence, finitely many Ci's are non-zero. Now I am not writing it again. You write it in your own language. This is the first part that we have proved. This is the first part. We have to write the proof of third part about degree. That I will do after a couple of minutes. You, up to this point, I have written the proof systematically. Up to this point. Okay. After that, I have explained you systematically by taking numerical example. But now, in your own language, you, with your own understanding, you write down couple of steps which will indicate that why Bn minus R is 0 in this summation and why AR is 0 in this summation, and conclude by saying every case Cn is going to be 0, hence finitely many CRs are 0. Okay, complete it, then we write the proof for third. So we have proved that if n is greater than a plus b, we have proved that if n is greater than a plus b, Cn is equal to 0, right? So now we have to prove C of a plus b is definitely not equal to 0. That is why if this happens, then C of x polynomial will have degree a plus b, right? That is the highest coefficient, highest power x term whose coefficient is C a plus b, and definitely this is not 0. That is what we have to prove now. And therefore, if we could prove this, then by definition of degree, degree of C of x will be degree of a plus degree of. Okay, so we have to prove this now. Let a plus b is equal to k. So C a plus b. Now C a plus b, if I want to write, how will we write now? C a plus b is equal to a0 b a plus b plus a1 b a plus b minus 1 plus a2 b a plus b minus 2 plus dot dot dot. Now important term for us is going to be a b b b plus a plus 1 b bola a plus b minus a plus 1. Right? This is what is our formula, a plus b minus r, where r is a plus 1. Therefore, we are doing this. Now, if you simplify, a gets cancelled and you get b minus a. Is it correct? Understood? A.
Sir, it should be V minus 1, not V minus A. A
Huh?
would.
Sir, it should be B minus 1.
it should be here. कुठे?
तर तुम्ही जे बोललेलं तुम्ही चुकून बी मायनस ए बोललेलं.
अच्छा, लिहिले बरोबर ना?
हो.
हा, ठीक आहे. Okay. So now I am erasing this, or let me keep it like that. Let me keep it like that. For this I will what will be the suffix? B minus 1. What will be next term? A plus 2. B, now here if it is a plus 2, it will be b minus 2 plus dot dot dot. Finally, last term will be how much will be the last term? Plus a plus b, b 0. बघा समजतंय का? Is this is going to be our definition. This is our definition of C of n. C of n.
Sir, that should be capital B, no? A plus capital B.
Here, okay. In sigma notation, let me write this down. Sigma r goes from 0 to a minus 1 ar b. We have designed this is as k, so it is easy to write k minus r plus a b b plus sigma r goes from capital A plus 1 till a plus b, that is k. Okay, ar b k minus r. So the same summation I have written it in this form. Now let us look at it. Okay, let us observe here. Okay, a plus b, b a plus b. We have got our example there, up. Yeah, okay. Now in our example, let me write it in black. In our example, a plus b was 5, a0 was minus 3, and ba plus b, that is b5 was 0, a1 was 1, b4 was 0, a2 was 2, b3 was 0. Okay. Now a3 was 1, b2 is also 1, a4 was 0, b minus 1, that is b1 is 1, a5, correct, b0. How much was a5? इथे मी काय लिहिलं चुकलं काहीतरी. How much is b minus 1? This is 1. अच्छा, ते ऑटोमॅटिक झालं वाटतं. Then this is a5. a5 is 0, b0 is 2. So these many terms we have, and the middle term AABB is 1 into 1, which is non-zero. Oh, so coefficient C5 will be 1. All other terms become 0. Here it is becoming 0 because these terms are becoming 0 because of B. These terms are becoming 0 because of A. Similar situation, but only one term in between is not becoming 0. Okay, so barring this black work, whatever I am writing is the correct proof. Black, whatever I have written, explanation. So I will finish the proof now by writing this is equal to 0 plus AABB plus 0 is equal to AABB. So Cn or C A plus B plus B is equal to capital AA, BB, and none of them is 0. AA is not 0. BB is not 0. Therefore, CA plus B is not 0. That is the largest term, and every new number, n natural number that we take greater than A plus B, we have proved that it is 0, implies by definition degree of C of x is equal to degree of A of x plus degree B of x. That is 2, 3, 2. Right? Here, this is 1, 2. चलो या लिहून of polynomials. Okay, division algorithm of polynomials. So I will just pause recording, complete writing, and then read it again. Okay, the statement of division algorithm is if A and B are polynomials over reals, B is not a zero polynomial, then there exists unique Q of x, which we will call quotient polynomial, and R of x, which is we will call remainder polynomial. Those polynomials also will be over real numbers, such that A of x is equal to B of x into Q of x plus R of x. And then as far as degrees are concerned, either R of x is a zero polynomial, because if B of x divides A of x, then R of x will be zero polynomial. But if B of x does not divide A of x, then R of x, degree of R of x is going to be less than degree of B of x. It is as simple as that. Maybe we will have one example and understand this. Suppose I have a cubic polynomial, 3x square plus 2x minus 5, and if I want to divide it by, say, linear polynomial x plus 1, degree of this polynomial, this is B of x, this is B of x, this is A of x. Okay, so I perform long division and find out what is Q of x. So I am writing Q of x here, x square, so x cube plus x square, subtract, you get 2x square plus 2x plus 2x, 2x square plus 2x. Arey what? 0, 0 minus 5. There is nothing. I mean, therefore, this is remainder. So Q of x is equal to x square plus 2x. R of x is equal to minus 5. Right? So if we observe degree of R of x is minus 5 raised to 0, which x raised to 0, which is equal to 0. And degree of divisor polynomial is 1. So this is true. If it was not there, if it was 0 here, then this was 0, then R of x is a 0 polynomial, either 0 polynomial or degree is less than strict inequality. Degree is strict inequality. And also there is importance to this word, unique. You will have a unique polynomial as a quotient polynomial, and you will have a unique polynomial as a remainder polynomial, right? So as I said, we are not proving this, we will prove it in some other lecture later on, but right now we will start applying it. P of x that is polynomial is equal to 3x square plus 2x or 3x cube plus 2x square minus x minus 7. Okay. How much is P of 1? सांगा जरा चला. Find P of 1. तुम्हाला काहीच कॅल्क्युलेशन करायला दिली नाही आज. How much is P of 1?
-3.
P of 1, if you want to find out, you put x is equal to 1. 3 into 1 cube plus 2 into 1 square minus 1 minus 7. Which is 3 plus 2, 5 minus 1, 4 minus 3. How much is P minus 2?
Sir, -9.
How much is P?
No, sir, it is not -9, I think.
सांगितलंस म्हणून लिहिलं ना.
So it's -21.
-21.
Yes, sir, -21.
जाऊ दे, P of हाफ तुम्हाला जरा आवड आहे. Minus 20.
-21.
And P of 3. Okay, find remainders. If 3x cube plus 2x square minus x minus 7 is divided by question 1 x minus 1, question 2 x plus 2, question 3 x minus 3, performing long division, get me the remainder polynomials. Observation is answer remainder polynomial. When you divide by x minus 1 it is -3. When you divide by x plus 2 it is -21. And when you divide by x minus 3 it is 89. Is it a coincidence or is it a rule? So why? So in other words, if I say it like this, if P of x is equal to a0 plus a1x plus a2x square plus dot dot dot, polynomial of x is over real polynomial, or let me call it as a of x only, unnecessarily not necessary to call P of x, let it be a of x. Let b of x is equal to x plus k, then r of x is equal to a of how do we write? Then okay, then a of x is equal to b of x not that works. A of x is equal to x plus k times q of x plus r of x by division algorithm. Then r of x is equal equal to A of k, opposite of k. Then R of x is equal to A of opposite of k. That is what you have done it here. When you put P of 1, you got remainder minus 3 and your divisor polynomial is x minus 1. When you put x is equal to minus 2, you got remainder minus 21 and your divisor polynomial was x plus 2. 3 x minus 3. K minus k x plus k. So maybe this is not coincidence, it is theorem. It has to happen like that. So why is it happening? Try to decode. X plus k is b of x, divisor polynomial. Hence by division algorithm, okay, what is the degree of x plus k? Degree of x plus k is 1. Therefore, by division algorithm, degree of r of x is less than 1. And that is, I mean, therefore, only number which is available is 0. Therefore, degree either r of x is a 0 polynomial means 0 or constant or maybe constant small r belonging to capital R. Okay, so division algorithm says a of x is equal to x plus k times q of x plus small r, which is going to be your r of x. Okay, put x is equal to minus k. What happens? A of minus k, whatever that a of minus k, LHS, is equal to minus k plus k times q of x. This is 0, therefore r is equal to a of opposite of k. Proved. It is because degree of k is 1, you don't have any choice but to have a constant as a remainder. If x plus k divides a of x, then the constant will be 0. Else it will be a real number r. So r of x is going to be a real number. And that comes out to be equal to a of opposite of k, because this term becomes 0. Doesn't matter what q of x is, it will be 0. This term will contribute 0 to a of opposite of k. Only term which will contribute to a of opposite of k is r. And therefore, r of x is equal to a of opposite of k. This is called remainder theorem. Very, very useful theorem eventually. And the proof is based on division algorithm. That is where we stop for the day. Okay.
तर एक रिक्वेस्ट होती